Hello everyone. In our previous video we have seen how to use scaling and build a logistic regression on top of PIMA diabetics dataset, right? And also actually we end up with a lot of questions on different classification accuracy metrics. We have seen a simple classification accuracy. We know how it works, right? It says it says like number of correct predictions made by model divided by total number of observations, right? But we have lots of questions, right? Like if you see here, how many diabetic patients are predicted as a diabetic patients, how many non-diabetic patients are predicted as a non-diabetic, diabetic as a non-diabetic, non-diabetic patients as a diabetic, right? So we have to know, how to find the percentages or weightages of this individual, the problems, right? So as I told you, right, that just classification accuracy will tell you the overall accuracy, but I wanted to know for the specific problem, right? Like I am only worried about the correct values, but the positive values, whether what is the percentage of the accuracy that my model predicted the diabetic patient as a diabetic patient. I'm more focused on this, or else I'm more focused on the non-diabetic patients where my model predicted as non-diabetic, right? Or the other way around, right? So if you want to solve this problem, what are the problem which I just highlighted? So we need a matrix called confusion matrix. The name says a confusion, but it's not that confused. Okay, don't worry, we'll try to understand how the confusion matrix works. If you see this screenshot, right, so we have actual positives, actual negatives. So if you compare with our example, the diabetes, non-diabetes, right? So where we can assume the diabetes as a positive, usually, yeah, diabetes is a positive and non-diabetes is a negative, right? And we have predicted positives and predicted negatives, right? If you see this true positive, which is in yellow color, right, it is actually positive and it is a predicted positive. See, which means it is a positive and also my model also predicted as a positive, which is called true positive, right? If you see here, how many diabetic patients are predicted as a diabetic, which is true, which is expected, right? So when you talk about true positive, if actual results and my predicted results are positive, then we call it true positive. When you see the true negative, if you say it is under the actual negative, which is non-diabetic, right, and it is predicted as a non-diabetic, which is predicted negative, which is called true negative, which means actual results and predicted results are negative. In our case, how many non-diabetic patients are predicted as a non-diabetic, which is called true negative. So maybe you can call it, the first one is a true diabetic or true non-diabetic, right? So when you talk about the false negative, right? So it is actually a positive, but my model predicted as a negative. I'm repeating again. When you talk about false negative, it is actually a positive, but my model predicted as a negative. That's why it is called false negative, which means it's not negative, right? Which means when a non-diabetic patient is predicted as a diabetic, I can call it a false negative, right? When you talk about false positive, right, actually it is a positive, but unfortunately it predicted as a negative. Clear? So when you talk about false positive, right, if actual result is positive, but unfortunately my model predicted as a negative, that's called false positive. So I'm just repeating again. True positive means if the actual results and my predicted results are positive. True negative means if actual results and predicted results are negative. These two are perfect, right? These two are dangerous, so we have to be very careful on these two, right? False positive means if the actual results is negative but predicted as a positive. False negative is if the actual result is a positive but my model predicted as a negative. If you see this, you can literally compare with this our diabetic data set, right? So now we'll take a simple example, right? Let's say we have a 15 observation, so 10 of them are true. Maybe instead of true we'll call it 10 of them are diabetic, non-diabetic, or 5 of them are non-diabetic, right? So now we are just filling this confusion matrix table for our understanding, right? So out of 10 true, right? So I'm just saying 8 of them are correctly predicted and 2 of them are wrongly predicted, which means out of 10, 8 are predicted as a positive, which is true positive, and the true are predicted as a negative, which is called false negative. Why it's a false negative? Because it is a positive but predicted as a negative. And out of 5 false, right? So 1 is predicted as a positive, right, which is actually negative, but it is predicted as a positive. And out of 5, 4 are predicted perfectly. That's why we call it true negative, right? Now as I said, right, so we have different uh, problems to solve. I want to know how many perfect positives, how many perfect negatives, how many perfect false positive, how many perfect false negative, right? So this confusion matrix actually will help to solve, right? So one of the commonly used metrics is a precision and recall. Actually what precision says is the proportion of correct positive results out of all positive or out of all predicted positive results, right? For example, right, if you see, right, so I'll repeat myself again. It talks about if a true positive versus all positive, all predictive positive, which means this is your true positive, and how many of things are predicted as a positive? 8, right? And how many else? False positive, which is 1, right? So out of 10 records, 8 are predicted perfectly, right? And 1 it is predicted as a false positive. It is a negative, sorry, it's a positive, but it predicted as a negative, right? Now if you see our the formula for the precision, right, so it talks about the true positive. So we have a true positive at our numerator. The denominator we have a true positive plus false positive. So when you talk about false positive, it is a negative but predicted as a positive, right? And what our formulas, definition says for the precision: a proportion of correct positive results out of all predictive positive results, right? See, this is a false positive. It is a negative but predicted as a positive. But I want to know the proportion of all our actual positives versus all the predicted positives. That's why in the denominator I have true positive, which is actually positive, plus false positive, right? If you see the proportion of all the positive results over the predicted positive results, in our case it is 88.9%. And when you talk about the recall, it is our actual positive cases, which is this: how many diabetic patients are perfectly predicted as a diabetic, right? Which is called recall. Recall says a proportion of actual positive cases. That's why if you see the formula, in the numerator we have true positive, the denominator we have true positive plus false negative. What is false my negative? This one. These are actually what is false positive, sorry, what is false negative. It is actually a positive but predicted as a negative, right? So that's why we are taking a false negative. False negative is supposed to be a positive, right? And what is the definition of recall? The proportion of the actual positive cases, right? That's why in the denominator we have true positive, which is actual, which is actually positive, which is predicted as a positive, plus false negative, which is supposed to be a positive but it predicted as a negative. In our case it is 80% recall. So precision and recall are the widely used the accuracy metrics in the classification world, right? And we also have one more metric called F1 score. What F1 score does is it will give you the harmonic mean of your precision and recall. What is harmonic mean? We know mean, right? Mean is like the sum divided by total number of observations, right? When you talk about harmonic mean, when you talk about the precision and recall, these are percentages. This is not actually numbers, right? When you want to take a mean for the percentages, you go for harmonic mean, right? If you talk about the F1 score for this precision recall, it will be 84%, right? So we are not done it. So it's not just precision and recall. If you see precision recall, it mostly talks about the positive cases, right? Where recall talk about the actual positive cases, right? Where the precision talk about the proportion of the positive results out of all predicted positive results, right? It only talks about the positive cases, right? So we have few other metrics called sensitivity and specificity, right? Sensitivity is also called as true positive rate, which is obviously the recall. Recall is the true positive rate. How many positives are predicted as a positives, right? The perfect true positive rate, right? So sensitivity is also called the recall, obviously, right? So we got it 80% here, right? And we have specificity, right? What this specificity is how many negatives is correctly predicted as a negatives, right? It is quite opposite to the recall, right? Recall says how many positives are predicted as a positives, where sensitivity says how many negatives are predicted as negatives, right? Which is this case, the second case, how many non-diabetic patients are predicted as a non-diabetic, right? Even if you see the formula, right, for the sensitivity and the specificity, sensitivity or recall, right? If you see the formula, so here we have true negative divided by true negative plus false positive. It is a quite opposite for the recall, right? And we have the other important thing called false positive rate, right? Which is this: how many diabetic patients are predicted as non-diabetic. When you talk about the false positive rate, the formula is false positive divided by false positive plus true negative, right? Yep. So true negative, right? So why true negative? So when you say false positive means it's actually negative but predicted as a positive, right? So that's why at the denominator we are taking the true negative, right? We also have false negative rate. So this is false positive rate. So we also have false negative rate, right? Which will tell you the percentage of the false negatives, which means a positive which is predicted as a negative, false negative rate, right? So when you talk about the formula for false negative rate, it will be false negative divided by false negative plus true positive, right? Clear? Why true positive at the denominator? Because we are worrying about the false negative. What you mean by false negative? As I said, it is a positive but predicted as a negative, right? So there are even more different classification accuracy metrics available, but these are the the widely used, right? So whatever we discuss is precision, recall, specificity, false positive rate, false negative rate. We talked about F1 score, right? So in F1 score again we have different metrics like F 0.5 score, F 1.5 score, F2 score. What it does is it will just give the weightage for your precision or recall, depends on the score you selected, right? So hope you enjoyed this video. So in our next video we'll try to find this recall, precision, false negative rate, whatever we discussed on our PIMA diabetics datasets. So till then, stay tuned. Please don't forget to subscribe my channel. Thank you.